I'm here to talk today about the 11AD radio. So one of the things that we've done is that we recognize that as campuses are truly becoming fully digital from edge to edge, from the time that you arrive at site with your chosen mode of transportation to the time you leave, you want to be connected, whether you're inside, outside, between buildings, underground. So one of the things that comes along with that is providing data in more places and extending the edge to where the edge of the campus is. And one of the ways that we're doing that is with our AP-387, that's the radio up top there. So this is a dedicated 11AD and 11AC radio. It's actually a dual radio platform with the two radios tied together. So when you look at the 60 gigahertz market traditionally, because it's been around for a long time, the links are fairly expensive typically. The antennas are highly directional and require specialized skill sets to deploy them. It can be quite difficult, and then you also have an aggravation that every time you get a strong windstorm, not like what's going on in the southeast today, you'll need to send that crew back out to the site to realign the antennas after you've had a heavy wind event. So that's got to be addressed. And the other thing is that 60 gigahertz is definitely exposed to the elements. If you're standing in a hurricane today and you're getting 4 inches of rain per hour, your 60 gigahertz link is probably not working. So we need to have a mechanism to fall back into something that's reliable in those conditions. And so this is one of the reasons why the 387 is actually a dual radio system. All right, so the things that we looked at and focused on when we were defining the 387, as you know, Arubas had a pretty successful outdoor business. And part of that comes down to the design ethos that we apply. We need to have very highly reliable radios that can go in the field and be left alone for periods of 5 to 10 years and continue to operate. So we're leveraging those design ideas. Simple things like you don't actually see a flat edge anywhere in our units. That's because gravity sucks and it pulls the water off the side of the unit. You don't want to have flat edges facing up. You don't want to have openings facing up. And you want to make sure that your unit is going to shed that water. You have to be absolutely focused on water when you're dealing with outdoor gear. The link is self-acquiring. We're going to demonstrate that in a minute. But the idea is that as long as the radios are very crudely lined up, the scanning range of the 60-degree antenna or the 60 gigahertz antenna is actually plus minus 40 degrees. So you can have a pretty crudely lined up system. The links will self-acquire. So I recall seeing a quote from a provider in this space that was only minutes to deploy and a half an hour to align. With this, it's only minutes to deploy and hold my beer. So we get rid of that, and it also means that you don't have to worry about the units being shifted out of their alignment because they will actually track movement if they're vibrated by the wind, if the wind moves the bracket somehow, or if there's some other disruption. Even to the extent that if they become blocked, they can actually engage the link through a bounce that's available in the environmental space. And that's part of the 11AD standard, so we've taken full advantage of that because, of course, the 11AD standard is supposed to track a user at walking speed as they're moving through a space, so that you can do the same thing with a point-to-point link.
Do they have the ability to handle some non-line of sight or some not near non-line of sight?
So the question is whether we can handle near line of sight or non-line of sight. So the first answer is no, because 60 gigahertz is a very high frequency and it travels like light. But the second answer is it does work off bounces, right? So if you have a large flat surface and you get a glint or a bounce off of that surface that's well defined, you can actually form the link around a corner.
Wow. So
that's a RF propagation thing.
So when you're saying bouncing, could you actually use that, or is there a serious efficiency loss from that bounce?
It depends on how well the surface bounces. If it's very rough, because of course at 60 gigahertz your wavelengths are really small. So it needs to be a relatively flat surface. You can't have.
Could you design around a corner?
Could
you design a bounce?
You could design a bounce.
Okay.
Right? It's not the way I would approach it typically. I'd be looking for a line of sight. But if you have a situation where you've got buildings around and you may end up being obstructed by a large vehicle, for example, the link has the opportunity to reform around that.
Are you coming?
Because remember, the antenna beam can sweep back and forth 40 degrees on both ends.
Yeah.
Right? Plus minus 40 degrees. The 5 gigahertz radio in there uses a fixed antenna. It actually covers the full field of view, because at 5 gig, building an antenna that can scan like the 60 gig, the thing would be huge. So the 5 gig radio is actually fixed, but it covers the same sweep angles, both horizontally and vertically, that the 60 gigahertz does.
How are you getting? Good. I mean, a lot of the competitors have their 60 gig equipment is a lot bigger.
Yes.
How are you getting all that awesomeness out of that little fella right there?
Okay, well, so for one thing, some of the traditional solutions, and this is one of the reasons why they require precise alignment, is for a 2 kilometer link, which is really sort of the maximum outer bound for 60 gigahertz systems. One of the big issues there is that you need really high antenna gain. And so what's driving the size to get to 2 kilometers is getting a large dish to actually give you that antenna gain. We are restricting this to 500 meters. So now, remembering that this is designed for a campus environment, there really aren't too many campuses that are much bigger than 500 meters. Like if you look around here, these buildings are all within 75 to 100 meters.
So it's purpose driven.
It is purpose driven, and we've limited the design to 500 meters.
With that said, are you going to have any external antenna capabilities?
We don't have any plans for an external antenna capability right now. Our feeling is that a 500 meter link is going to cover sort of 95% of the addressable space. And if you want to go beyond that, the traditional solutions will fill that, because we don't want to encumber 95% of the opportunity with 5% of the design.
Scanning antenna, are you talking about mechanical scanning of an antenna? Or
No, this is all electronically
steered.
So this is part of 11AD.
AD, yeah.
The antenna solutions that are coming both from the antenna vendors themselves, along with our chipset provider, those things have that scanning capability built in, so it's electronically scanned. So if you actually open this up, you'd find 2 high gain directional antennas in there.
I'll open it up.
On a different day, maybe, Sam. Okay. But yeah, if you open it up, you'll see there's 2 panels in there, with each with 60 antenna elements on it.
Okay.
And then we're actually building the array across there. So
Dynamically.
they have what's called a code book, which basically defines how you set up each of the individual antenna elements for all of the different scan angles.
So just standalone, so if I'm not an Aruba customer, I can buy these and get my bridging?
Correct. So like every other Aruba radio, these operate in instant or in controller mode. So that you can, in a standalone setup, the instant mode is the way that you would engage it. And that's true for our traditional mesh radios as well, using Wi-Fi.
Another follow-up on that question. You've got 40 degrees east and west?
Yes.
So an 80 degree.
It's plus minus 40
and
scan.
what's the actual beam width of the?
It's around 10 degrees. Yeah. Okay. That also means which is also an interesting thing, because the loss at 60 gigahertz is quite high. You can actually co-locate 2 of these things probably about 4 or 5 meters apart. We still have to do this test, but my expectation is about 4 or 5 meters you can reuse the same channel.
Oh, because they're that tight.
Wow,
Yeah,
nice.
10 degrees is that.
Yeah, because of the narrow beam width, and at 60 gigahertz in 1 meter, you lose 68 dB of signal, right? So I've got lots of inherent isolation at 60 gig.
That's something that you guys have deployed today, or still sort of in testing, or?
We haven't sold one of these yet.
Oh, okay.
That'll be soon. But yeah, we are. These are all the test cases.
I wouldn't mind that.
These are all the test cases that we're running through in our design verification.
I mean,
It
with
is one of
transparency, I mean, you could probably do that. Just the nature of the frequency band that's in use there. I mean, this isn't unique to you being able to reuse.
That's true.
the channel,
This is a function of the physics, right?
Yeah.
But this is one of the reasons why we think 60 gigahertz is interesting. We do think that with IoT and all the other bandwidth demands that are coming to the network, you need to extend the edge of your system or provide bandwidth in more places. Okay, so we're reusing the mount hardware. That's been one of the huge successes of the 270 series. So we've got a flush mount that you can see there that screws into the wall. You drop the unit in, and there's one bolt that goes in. This is a really important thing. When Aruba is engaged both on the 270 and 370 series, and now this product, I'm a huge fan of simple, right? So I wasn't going to engage this if we were going to do a traditional 60 gig solution that required a specialized expert to go out and deploy it. I want to be able to hand this to any of my partners with 15 to 20 minutes of training and have that installed 100% of the time correctly, right? And this thing is really forgiving in that regard.
There's a question from Twitter on, is there going to be available an external antenna version of this?
No, we're planning on this being the sole offering, at least for the time being.
Thanks.
Because again, if you go with the external antenna option, you don't have access to the scanning, right? So we have to maintain the scanning, and that means you work with panels. One potential variable over time is that you could expand the number of sub-panels that are inside the design. to allow you to get another, another maybe doubling of the distance. But that would be the antenna solutions today are quite sophisticated, and they use exotic materials. It's cold-fired ceramics is what the patches are printed on. So there is a lot of costs associated with the panels. So it's a real tricky trade-off between how much distance you're supporting and how much cost you're embedding in the product. Okay, and then we're aggregating the throughput, so both radios are active at the same time. So we're getting, certainly at this distance, we're getting about 600 megabits per second through the 11AC radio, and up to 2.5 gigabits per second over the 5 gig radio. So what we're anticipating is being able to support aggregate bandwidth sort of bidirectionally in excess of a gigabit per second.
And how are you doing load balancing across those links? Is that?
That's a really great question because it has to be dynamic, right?
So
the question was about load balancing. So this is what my engineering team is working on. The algorithm basically, so if you get a rain event, for example, your 60 gigahertz link is going to go away. So it has to be link aware so that the radio can back down the packets that are going to the 60 gig side, push them over the 5 gig and back again. So aside from the details, I'm leaving that to my engineering team to make that work for me.
You said 600 meg on 60, or did I have that backwards?
No, 600 meg on the 5 gig.
On 5, okay.
Right, because that's two 11AC channels at 80 megahertz wide.
Okay.
And then 2.5 gig is what you get out of running QPSK on the 60 gigahertz radio.
So some competitors have the ability to do full duplex yet, or is that something that you guys are working on with the PCP? Or?
So the inherent latency of 11AD, because the interface itself is so much faster, the latency associated with running it in TDD mode, which is what we're doing, is not that bad. And at 60 gigahertz, one of the issues is there's really only two channels. Because the way the FCC has defined it, the lower channel is actually going to give you out-of-band noise issues. So you can't really duplex two channels, right? So we're doing TDD half duplex. But the symbol rate is 1.75 gigasymbols per second, right? So your actual latency is really short. Okay, so this is the breakdown of the product with some internal details. So it is a PoE port. It's a single gig, but remembering that an Ethernet cable is a gig in each direction, which is also what I'm hoping we're going to push over the radio. So if you've got more than a gig flowing in one direction, it'll have to queue up. 60 gig antennas on the bottom. I apologize if I'm blocking some of the views here. 5 gig antennas on top. This is also where our BLE radio is as well. This has BLE like the rest of our outdoor stuff. The bracket that I showed you and the main board. So it's a fairly straightforward thing. One outdoor nerd item that I'd like to point out is right up here, you'll see under the 5 gigahertz antenna, there's a little lip there, and that acts like an umbrella. The problem with 60 gigahertz is it's very sensitive to water, so if you get sheeting of water over the face of it, this gives you a drip edge. Because I've seen some products in 60 gig that are implemented with beautiful smooth surfaces, which is a great way to make sure that water funnels over the 60 gigahertz antenna. So we provided an umbrella feature built into the chassis.
Very nice.
So I'm going to turn this over to my colleague.
Just before you go there, how are your APs handling heat from sun and solar?
So first of all, we use industrial chipsets and everything.
Yep.
Everything inside can handle that. Our chassis.
Maybe just the outer casing itself, like
the outer
handling the elements, itself.
Okay, well, I mean, it's standard thermal design, right? So these are heat fins. They're actually there for a reason to increase the surface area. The whole back plate is aluminum. It's a solid, it's a cast aluminum chassis, which has a really good heat conductance. Mm-hmm. All of our radio designs, our radio boards actually sit directly on the chassis, and there's very thin thermal pads between the board and and where the heat's being generated. So the PAs are sitting on a thermal pad, which allows the heat to go out the back.
So there's no need for a kind of a solar shield or cover to help out your stainless steel screws or anything else that you've got.
Yeah, for two reasons. One of them is that the actual top surface is quite small. So that's where most of your load's going to be. And when you're on the backside, you're either going to be protected by the building you're attached to or by the structure you're mounted to. So that's all factored in. We assume a 2-inch pole when we do our thermal modeling, and we assume that the sun is going to increase the temperature by about 10 degrees Celsius.
Right. Because in some installations, it could be on top of a building, like out open space, right?
Sure.
Where you've got it there in a way.
Yeah.
Right?
Yeah, but I mean, this is what we do all the time, right? We've got, if you look at the traditional outdoor stuff, we've got 500,000 units deployed globally. So.
Got one question from Twitter asking if there's going to be any SFP support.
No, we're not planning any SFP support on this product now. Part of the issue with SFP support when you're outdoors in particular is the second question you have to ask is how you're going to power it. So the single port that's on this device is providing power and data. And the only way you can do that is with PoE.
All right, so we have a simple UI that we custom built. Actually, we built this for Atmosphere to showcase a little bit larger demo scenario where the AP-387 was a part of it. And we did a failover of the whole event network, having 2,200 people using network, cutting the cable and show that the failover is happening seamless using our branch gateways. But since we have the UI, we're just reusing that for showcasing what's happening right now. So we can see that we are just under a gig of throughput right now with some IPF traffic. And we can see just easily when I'm blocking the traffic, well, blocking the AD radio, you'll see that traffic is dropping quite a bit.
Okay, that's failing over to the 11AC radio.
Yeah. And it should be catching up again pretty quickly. So you'll see that it's back right away, back up running again.
So that's your rainstorm passing in and passing out, right?
Yeah.
So that's why the system's designed this way. You don't want your link to disappear, but it's acceptable to slow down for a short period while you're dealing with the heaviest rainfall.
What's the design issue for that 5 gig redundant side?
Yep.
From a frequency reuse where you're placing these?
Yeah, you'll have to do you have to traditionally deal with the traditional issues associated with the 5 gig frequency assignments. But this will work the same.
But you're pulling 280s?
So there's the single 80 megahertz channel running right now.
Oh, okay.
But it could be a 20 megahertz channel as well, right? So it will adapt to the environment you're in, but it's really there as a failover if you lose the link, and we're taking advantage of the bandwidth. To whatever bandwidth is being provided by the 5 gig is being added to the capability of the 11AD radio.
So now, and also what we're going to show is when we turn this away to show the beamforming, and you'll see that the bandwidth is barely dropping because of the beamforming keeping up.
Yep, there it goes.
Yeah, so you see it's reestablishing itself. So just retuning the beamforming on it, and it gives approximately the same bandwidth.
Yep.
See, this is a line of sight, so it works pretty well.
Okay. So that wraps up our portion of the presentation. If there's any quick questions, and
I got one
we've got a larger
question
session.
from Twitter asking if there's smart rate on the 387.
No, right now it's single Ethernet port. Again, with smart rate, one of the things that we have not firmly established yet is the ability for outdoor quality power injectors that have surge suppression to actually be able to handle more than a gigabit per second without capacity loading the lines. So we've stuck with traditional solutions that we know that work, but these are things that could be enhanced with further generations.
Maybe I missed that. What was the PoE requirements you have?
Sorry?
What's the PoE requirements?
So what we're seeing right now, the original thought was that it was going to come in requiring AT power. It looks like we're going to be able to run on, if it's running on AF, it will give you an alarm condition, the LED will come on, but it will operate with the 60 gigahertz radios backed off by 3 dB. So it looks like we'll get most of the function on AF, but AT is recommended.
So all the testing we've been doing now, before this, we are running at max 13 watts.
Okay.
Wow, that's not bad at all.
Not that bad. And it's just strictly PoE, right? There's no other place for other adapters whatsoever.
It's PoE only, yeah.
PoE only.
Because so if you look at the way that our outdoor gear ships,
Yeah.
96% of our gear ships today, and it uses PoE. Our outdoor gear is all done that way. Again, because of this problem, we have fiber supported on our new generation of outdoor. But the second question is like, well, where do you get power? Always falls back to, I need a PoE injector.
Light standard?
Yeah,
DC?
the problem is you have to hire an
meter too?
electrician to do that versus a low voltage guy, right?
Right.
So
I guess, yeah.
we can certainly discuss that offline.
Yeah.
But if you actually look at our field statistics, we used our customer information, and that's always taken into account when we look at defining a new product. And our customers tell us that 96% of the time, 97% of the time, they're powering the units off PoE. And if they're not, they're putting a PoE injector at the bottom of the pole, so that gives them an Ethernet cable to plug into the unit. So.
Right, yeah, for sure.
Okay, so I'm gonna let Onno take over, and there is a more general Q&A session at the back. So.
Thank you, Eric. Welcome, everybody.
Right here.
I'm Onno Harms, product management team. I'm responsible for indoor access points. I'll be talking about 11AX after this. I guess over the last couple of days, you guys have been hearing quite a bit about 11AX, probably in every session. And I'm also assuming that most of you are fairly familiar with the technical details on 11AX. So I'm not going to bore you too much with that. I'll have a couple of slides on that, and then I'll dive into our view on 11AX, what we're planning with 11AX, and what's coming out pretty quickly. Nevertheless, just want to repeat some of the original goals of the 11AX task group when it was kicked off many, many years ago. One of the goals was to increase the average throughput of a typical user in a dense deployment scenario with typical user traffic. So not a lab setting with big TCP packets, but a typical user deployment. And when I say dense, that starts at over 100 clients per AP and less than 2,500 square feet per AP as well. Also, it is important with 11AX to enable client devices to do power savings, to save power. So it's in the 11AX standard has a goal to enable power savings on client devices. And that obviously directly translates into battery life. So quite interesting for some of the client vendors out there. Also, we're going to still higher peak data rates. The peak data rates on a single client will still go up from where we are with 11AC. And at the same time, we are supporting many, many devices, deployment with lots of devices that actually need very small amounts of data. Think of IoT, lots and lots of IoT devices in a shared environment. At the same time that you have very high throughput devices, you'll also have tons of IoT devices, and that will 11AX will enable that as well. And finally, 11AX also had the goal to enable more robust and longer range outdoor links. Some of that will come out in later versions of the 11AX products. Will initially not be there, but that's definitely a goal of the 11AX standard. Okay, so why should you care about 11AX? First of all, it might solve a couple of problems that you already have today. I mentioned already that in dense deployments with lots of client devices that have increasing bandwidth demands, you will see today, even with the latest and greatest 11AC technology, if you have 100 clients associated with an AP and those clients are pushing a lot of data, you will see some degradation there. If you test an AP with one client or you test it with 100 clients, you don't just simply get a % of the bandwidth. The overall performance of that AP will degrade quite a bit. 11AX will help with that. You may have networks that are ready for a client density and client demands now, but with more and more clients coming into your network, more and more demanding clients coming into your network, and the mix of clients changing, that might turn out to be a problem in the near future or in the further future. Most of our customers, of course, they deploy networks now with the idea that those networks will stay around for 5 years or longer. The improvements you will get, first of all, 11AX is all about improving system efficiency. And that, again, will help you to increase the average throughput of a device in your network by that factor of 4 at least. Significant power savings opportunity for your client devices. You have the ability to really have dedicated, optimized data pipes for specific devices. You could potentially reserve a channel or have a dedicated slice of data rate available for particular devices in your network. And then obviously, again, it will result in more optimized and more robust and longer range outdoor links. So some of the concerns that we hear from our customers and from people in the field. There are no client devices yet. True. They are coming pretty soon. From what we hear, they're coming maybe later this year, but definitely more leading edge clients will come out in 2019. The current products that you see with 11AX are not stable already yet. That is true. There are some products on the market today that are being offered, not quite ready yet, but that is changing very, very rapidly. Then one of the concerns that we always hear is, I will have to upgrade my network to support 11AX. That may be true in some situations. If you want to take the maximum out of 11AX, you may need more power for your APs. You may need smart RAID or multi-gig ports. But you can start off with your existing infrastructure and start deploying 11AX as well.
So we've heard it from other people, and X is now the thing. So how is it going to do with our clients now?
So that's an excellent question. 11AX, well, first of all, 11AX is fully backwards compatible, both on the client side and on the AP side, right? So the first deployment of 11AX APs in the market will be 11AC deployments, right? All your clients are 11AC. You will get marginal benefits from the fact that you have more radio channels. You have more chains on your APs, which will give you some benefits. You also will have an infrastructure that is beefed up. The CPUs, the memory footprints on those new access points will be much higher than what you get today on AC because they're designed to deal with much higher client densities. So you will see some advantages of that. But purely on a Wi-Fi perspective, you will have limited advantage.
Do you think that's going to be a hard sell to people right now while there's no really benefit to going to an AP other than the horsepower that comes with it? I mean,
Sure.
to me, it sounds awesome because I understand that the horsepower is good, but
the question at some point, I mean, a hard sell. First and foremost, 11AX is just the next standard of Wi-Fi, right? And as every time I have a slide, I talk about the expectation on cost. That's too expensive. It might not be. You may be able to buy 11AX at a very similar price point as AC. So then the question becomes, why not?
Okay,
right?
yeah, fair.
Why not be prepared for the future and go to 11AX? You may want to wait for that stability to hit a point where you think I'm ready to jump in, but the cost premiums will be pretty marginal unless you want the highest end, the flagship, the monster AP, right?
It's typical in a situation like this, I guess, to make the price point a little bit more competitive with the previous lineage.
Yeah, and also with the AX APs, I can't go in a lot of our roadmap discussions and details on the platforms, but we will not just bring 11AX. There's a lot of other things that will happen at the same time that make that platform, even if you ignore the AX part of things, make that platform potentially interesting for use. Personally, I think they look better than the current ones, but that's a whole different.
I agree. We talked about that offline, and I'm on board with you there.
Okay, cool. So yeah, I already covered the too expensive. That's some of the concerns that we hear as well. Okay. I'll go quickly. When does it become a reality? As you probably know, the standard will not get ratified until late 2019. I think everybody is on board with that. That doesn't stop us from building products, of course. Wi-Fi Alliance certification program, also late next year. I mentioned a couple of mandatory and optional and not in the first wave of 11AX certification program there.
So with these, I'm assuming you have an AXAP up there.
Mm-hmm.
Is that AXAP going to be software upgradable to?
Absolutely.
Okay.
I say absolutely to the best of our knowledge, I have to say, right? The things are not frozen, but we feel very strongly, and that's why we're not jumping in too early with premature products. We're jumping in with product that we feel very confidently can be software upgradable to pass the release one, wave one, I guess, of the Wi-Fi Alliance certification program. Absolutely.
Do you have an example of specific radios that are on the market today that you're confident will not be upgradable?
Yeah, I don't want to talk about competitors, but there are products out there we know are using early chipsets that cannot pass some of the mandatory requirements, specifically some of the things around OFDMA uplink. You can call those partially 11AX or pre-11AX, but that is one of the steps that we decided not to do. So we got a question, why are you not there with the product yet? Well, that's one of the reasons. We want to have a product that is fully certifiable and it's ready to go. And stable enough as well.
And as a customer, I would say, I know you guys probably get a lot of those questions from non-wireless engineers. You probably get a lot of those types of questions from business people. I think I can speak for a lot of wireless engineers who are really happy that you're not trying to push something that's not ready. I mean,
appreciate that.
I think all of us can agree on that.
Okay. So yeah, I mentioned it here as well, right? Some are not software upgradable, some may not be stable enough yet. Client devices, talked about that. APs coming quickly, and yeah, switches. In some cases, if you want everything out of 11AX, you may have to upgrade your switch infrastructure, but you don't have to. So our view, our roadmap. Of course, we always like to be first or definitely early to market, no doubt. We try to be early with every standard change. It's a great opportunity to gain some market share, frankly. But it's important, and as we mentioned before already, that those APs can pass the wave one requirements with software upgrades only. And also that those platforms have the capabilities and functions to really deliver what 11AX promises. You can't have an underpowered platform and just bolt on 11AX. Future-proofing without early adopter pain. So yeah, we don't want to bring products to the market that are not stable. That will bring your network down, that cause all kinds of problems. So again, we're taking a little bit of a more conservative approach maybe. Differentiating features, we talk about that as well. It is not just 11AX. There's other features that will come with these products that will make them very competitive, I feel. And also, our intention is to work on a full portfolio of 11AX APs, not just a point product. And yeah, in summary, starting late this year, we'll have our first products launching. And ultimately, these are the 3 initial products. It'll grow from there. These are the first 3 products that we'll bring out in the market. Over time, no surprise, the entire Wi-Fi portfolio will move to AX, but this is what we start with. And I have some samples here. These are not renderings, not pictures that I just blew up. These are actual products. They're actual prototypes. They're also not mechanical samples. You can light them up if you want, but we didn't think a demo of just another Wi-Fi access point is all that interesting, and you just can see it beaconing. But anyway. Any questions? I know, I'm sorry, I accelerated a little bit at the end, but...
The asterisks on the PoE for those,
yes.
Does that mean you don't really know for sure? Or?
No, we know exactly, but it's a good question. Thank you for reminding me. So we do not require you to go to BT on this one. So even though we support BT, we actually support BT on all of them. We don't force you to go to BT. We're doing something smart with AT. You can keep your AT switch infrastructure and operate these APs, even the 8x8 one, without any restrictions. The details on how we do that, we can talk offline maybe, but it's something that we'll do. You don't have to go to BT. You can still operate them without restrictions.
But you don't like lose half the change or something?
Nope. You're on 2 cables. Okay, maybe that tells you enough, right? Yeah.
Okay, that answers
and the reason I'm
putting an ATAP, and then it's never mind. You win.
And the reason I'm putting an asterisk here is that AP operates almost without restrictions from a single AT, but some minor things might not be there.
So will the 515 work on AF?
Yes, AF no. It will work. Sorry, no. It will work on AF, but you would be foolish to do so because you invest in an AX infrastructure and then you operate it on AF, and it's really not going to work all that well. It'll probably be a dual 2x2 or something like that.
That's when they sell you the switches.
Worth asking. And the 5050, that's the Ethernet interfaces.
Sorry, what?
The 5.0/5.0, that's Ethernet interfaces.
Yeah, sorry, that's a 5 gig, dual 5 gig.
Total aggregate throughput of 10 gigs.
Well, you won't get the 10 gig. There is no use case you can do with those. Even an 8x8 radio, those 8x8 radios will operate in 80 megahertz max, or you'll drop to 4x4 with 160. You cannot build a case to go to 10 gig. You can very unlikely to make a case to go.
Material?
Sorry, what?
Make sure that ends up in the marketing material. You're not going to get 10 gig out of those 2 Ethernet lines.
You won't have a problem with a single 5 gig link. I can guarantee you that. Okay.